Hey everyone, and welcome to this explainer. Today, we're diving headfirst into the world of IT support by cracking open CompTIA A Core 2 Domain 3. This domain focuses heavily on software troubleshooting for the new 220-1202 exam. You know, when you really think about it, IT technicians act a whole lot like digital detectives. The clues are error codes, the suspects are faulty software, and it's our job to solve the mystery.
Okay, let's dive right into this syllabus step by step. We'll start with decoding software troubleshooting, then move on to taming Windows OS errors. After that, solving mobile device mysteries, defeating security threats, and finally, we'll wrap up with the troubleshooting methodology. All right, Section 1, Decoding Software Troubleshooting, the stakes of Domain 3. To put things into perspective, Domain 3 makes up a massive 23% of the entire Core 2 exam. That is nearly a quarter of your total score dedicated entirely to software troubleshooting. So, mastering this, it is absolutely crucial. It means knowing exactly when and how to deploy the right tool into a broken system.
Now, what's really interesting about this transition to the 1202 exam version is how they've modernized the intelligence gathering. Older, more niche topics like airdrop troubleshooting, they're out. Now, the focus is squarely on the modern threats we face every single day. Things like app installation failures, OS update failures, and constantly fighting off those incredibly annoying unwanted OS notifications. It's a highly realistic approach to what users actually struggle with today.
Moving on to Section 2, Taming Windows OS Errors, the scene of the crime. Imagine a user staring at their monitor in absolute terror. They've just been hit with the infamous blue screen of death. It makes you wonder, what is the very first thing you should actually do when encountering a BSOD? You can't just guess here, right? You need evidence.
And it's all about matching that evidence to the proper investigation protocol. Seen that blue screen? Your absolute first action is to note the stop code. That code is literally your primary clue. Now, if the system won't boot after that, a system restore might roll it back to a last known good state. What about random applications crashing? For that, tools like the Event Viewer and Reliability Monitor are fantastic for tracking stability over time. And if you suspect corrupt OS files, you're going to want to run SFC, the System File Checker, using the Scan Now command. Finally, if the PC boots up and just says no OS found, honestly, check if a USB drive was left plugged in or check the BIOS boot priority.
And this brilliantly illustrates how we break down other common issues too. Sluggish performance? Check Task Manager to see what's hogging the CPU. Low memory warnings usually point to an app memory leak, which is basically an app refusing to release resources, or lack of virtual memory, which acts as a sort of slow overflow RAM. If certain services aren't starting, you need to verify their dependencies in the services utility, because one service almost always relies on another to function. What about a slow profile load in a corporate office? That's typically domain network latency when the system is trying to sync roaming user profiles. And lastly, time drift. If a computer's clock gets out of sync, you are going to get constant certificate errors. The quick fix? Just sync it with a time server.
Let's shift gears to Section 3, Solving Mobile Device Mysteries, Investigating the Smartphone.
We carry these things in our pockets every day. So when a user taps an app and it immediately crashes or just hangs indefinitely, it's a pretty urgent mobile mystery. So what is the exact step-by-step protocol for this specific scenario?
Let's walk through how this builds, because the sequence is incredibly strict. Step 1, force close the application. If that fails, Step 2 is a simple restart. This clears out temporary files and memory for much-needed clean slate. Step 3 is checking the App Store for an update, because hey, the developer might have already fixed the bug, and as an absolute last resort, Step 4 is completely uninstalling and reinstalling the app.
Environmental clues often point directly to the root cause of other mobile headaches too. A rapidly discharging battery usually means high utilization background apps are secretly draining your resources. Getting connection timeouts while trying to stream HD video? If you only have 2 bars of a 3G network, well, that's simply insufficient bandwidth. And if auto-rotation completely stops responding, first, make sure the screen and case are clean, then restart the phone to refresh the gyroscope sensors, or, in worst-case scenarios, perform a factory reset.
All right, Section 4, Defeating Security Threats, Uncovering Malicious Actors. We have to talk about the darker side of troubleshooting. Ransomware is a massive, massive threat today. It's a severe type of malware that encrypts the user's files and literally extorts them for a financial payment. The core concept to remember here is file alteration and extortion. If a user suddenly can't open any of their documents and gets a nasty pop-up demanding cryptocurrency, you are absolutely dealing with a ransomware incident.
Equally terrifying is the zero-day exploit. This is an attack that targets a software vulnerability before a fix or patch even becomes available. It's called zero-day because the good guys have had literally 0 days to fix it. It's an incredibly dangerous time frame where the virus is out in the wild, spreading, but the antivirus cure doesn't even exist yet.
So, knowing how to respond to these threats is vital. The crucial point here, and CompTIA loves testing you on what to do first, is that step 1 is always isolating the infected system from the network. You have to stop the malware from spreading to other machines. Once isolated, step 2 is disabling system restore so the malware can't hide in your backups. Then, remediate by updating your anti-malware and running a full scan. Finally, train and educate the end user so they don't click on that sketchy phishing link again.
Finally, Section 5, the Troubleshooting Methodology, the Detective's Handbook. These 6 steps right here are the absolute backbone of the entire troubleshooting process, especially for those simulation-style performance-based questions you'll see on the exam. First, identify the problem by gathering evidence. Next, establish a theory of probable cause. Then, test that theory to confirm it. After that, establish a plan of action and implement your fix. Step 5, verify full system functionality. Make sure you didn't break anything else. And finally, document your findings, actions, and outcomes. It's a fantastic reminder not to jump straight to a dramatic solution without following the official protocol.
And that brings us to our final and perhaps most impactful thought. Good troubleshooting is controlled skepticism. It means never blindly trusting the first symptom you see. You always have to verify the clues, test your theories, and follow the methodology. So, as you step into the world of IT support and face down Domain 3, what will be the first digital mystery you solve?